So here is a question on a graphical solution to a trigonometric function that we're asked to copy and complete the table of values for the relation y is equal to 3 sine 2x. And here is the table of values. So we're told to use a scale of 2 centimeters to 15 degrees on the x-axis and 2 centimeters to 1 unit on the y-axis to draw the graph of y is equal to 3 sine 2x for values of x ranging from 0 to 150 degrees. Okay, so we are to use a graph to find the truth set. This statement means that we should find the solution of these equations, and in the first case 3 sine 2x plus 2 is equal to 0 and 3 over 2 sine 2x is equal to 0.25. So like we're told, our first mandate is to copy and complete this table of values for the relation y is equal to 3 sine 2x, and we are going to be taking values of x from 0, 15, 30, 45. But we need to note something. This is where students most likely will make mistakes. You will forget that we are told to use 2x. Look at this question. It is 3 sine 2x, and I'm going to show you on the calculator how you can do that seamlessly. So if you bring in your calculator, this is a very good way to do this. This is just a basic calculator, not too scientific, but you can actually play around it to also try and see how to solve it. We have 3 sine 2 times. Now we now need to input the values of x as we are given on the table. Like in the first case, we have x is 0, so it is 2 times 0. So I can close the bracket and say this is equal to what? It is 0. And you can see as it was given on the table, we have the value of y to be 0 when x is 0. So that was given already and we don't have any problem with that. But what about the second situation in which the value of x is 15 degrees? So you can just press the back button on your calculator, and instead of 0, you put in 15, and this is going to be 3 sine 30 because 2 times 15 is 30, and that will be 3 over 2 because sine 30 is 1 over 2, that's half. Then times 3, that will be 3 over 2. So you can just express this in decimal, and that is 1.5. So here we have 1.5 as the value for y, and then just like that we will continue by going back to change the value of x. And here in the next one, we've done the one for 15, then we need to do the one for 30. So 3 sine 2 times 30, and you can see the value here in decimal place is 2.59807611. But if you notice the consistency with which they input these values, they are given in one decimal place. So we need to convert this also to one decimal place. And if we are going to do that, that means that the 9 that is after the decimal place we want to take, we either round it up or round it down. In short, numbers between 5 to 9, we need to round them up to 1 and add to the number just before them. So 9 we take as 1 and add to 5. So we have 2.6 as the value. So here will be 2.6, all right? And then we can just go on like that. When x is 45 degrees, instead of 30, we have 45. What's that solution? That is 3. We want to put it in one decimal place. That will be 3.0. And then when x is 60, you just want to change this. So this is 60. So what's that? This is also 2.6 in one decimal place. So this is 2.6. And on like that, you can just input all your values. When x is 90, so what's the value for y? Y will be 0. So this is 0.0, just like they did here in the first case. So when x is 105 degrees, 105 degrees, okay, y is minus 1.5, minus 1.5, and then when x is 120 degrees, you can see I'm being consistent such that I'm not going to make mistake of forgetting to multiply by 2. So this is going to give me minus 2.6 in one decimal place also, okay. And finally, when x is 135, 135, what's the value of y? That will be minus 3.0 in one decimal place. So that is a very good means in which you can be sure that you won't make any mistake by forgetting to multiply x by 2. Okay, so that is the first mandate. We have copied and we have completed that table as requested. So we can now, before we draw our graph, okay, before we come up with the solution to the graph and plot the graph. Let's look at this question 6c, in which we are to find the truth set of 3 sine 2x plus 2 is equal to 0 and 3 over 2 sine 2x is equal to 0.25. Now, the mandate for us is that we should try as much as possible to reflect y in these particular equations. And in the first case, look at what we are given. In the first case, we are told that 3 sine 2x plus 2 is equal to 0. And looking at the equation, look at this. We already know that y was given as 3 sine 2x. And that means that this first expression in the equation is nothing but y. So we can say y plus 2 is equal to 0, such that the value of y will be minus 2. Now, minus 2 is just a constant, so it's not depending on x. There's no variable that is being reflected there. We just know that y is minus 2. So it's going to be a straight line graph that is constant across the axis of the x values that we are going to be considering, okay? It's going to be constant across the x-axis of the graph. So that's just y is equal to minus 2. What about the second case, in which we are told that 3 over 2 sine 2x is equal to 0.25? Yes, already we know that 3 sine 2x is x. So this particular equation, I can rewrite it to be, this is the same as 1 over 2 multiplied by 3 sine 2x to give me 0.25. And look at this, 3 sine 2x, is that not y? So I can just write y and say this is 1 over 2 multiplied by y is equal to 0.25, and I can say this is over 1. So if I cross multiply, that means y is equal to 2 multiplied by 0.25, okay? And 2 multiplied by 0.25 is 0.5, okay? So y is 0.50 here, and here we have y is minus 2.0. So for the two of them, the value of y is constant, so it's not going to depend on x, meaning that it's going to be a straight line graph that is running across the length of the x-axis. It is just constant, minus 2 in the first case, 0.5 in the second case. So now that we have all that we need to plot our graph, we can go ahead to plot our graph and find the truth set of this solution as requested. All right. So we need to look at our table of values to see how we can divide the graph to accommodate these values appropriately. It doesn't need to be at the origin, at the center. We just need to look at the values that we have, and it's going to help us to know where we can put the origin of the graph so that we will be able to input all our values as appropriate. Now, if you look at the values for y, you can see that y is increasing in the positive and the negative axis. So we can just know that. That means we can divide the graph into two equal parts to cater for y. So we can just go ahead to do that. Now for the x, we have how many values for x here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are 11 values for x, but the graph, the standard graph, is ideally 12 divisions. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that means I can actually choose to start from this particular first box, and it will be able to cater for all the values that we have. So vertical axis can be drawn here just to cater for all the values of x that we are noticing on the graph. So we can just draw our straight line there, the origin 0, and this is the positive y, okay, and this is the positive x. Okay, so now if we want to scale appropriately, we've been told that we need to have 15 degrees represented by 2 centimeters on the x-axis. So this will be 15, 30, 45, 60, 75, okay, and 90, 105, 120, 135, and 150. All right, so it's because I was able to scale my graph correctly. That's why you can say from 0 to 150 they are taken appropriately on the x-axis, and then on the y-axis 2 centimeters to represent 1 unit. So this will be 1, this will be 2, 3, and 4, and 5. Okay, and this will be minus 1 because we have negative values, and minus 2, minus 3, minus 4, and minus 5. So our scale on the graph is quite interesting. We are done and dusted with that. Then in that case, we now need to look at how we can plot these values to one another. Like in the first case, when x is 0, y is also 0. So here at the origin we have x is 0 and y is 0, and I'm using my blue ink to indicate that so that students out there, you can see this clearly. Okay, so when x is 15 degrees, here 15 degrees, y is what, 1.5. so this is 1, okay, and this is 2. In between them is going to be 1.5, but for x that is 15. So I can just say I want to trace like this, 15 going up, okay, and then 1.5 coming in between 1 and 5, and the point of intersection here is the point that is corresponding to x 15 and y is 1.5. So I will just note that, and I can just directly notice it is going to be here. All right, okay, so when x is 30, y is 2.6. so this is x is 30 here, y is going to be 2.6. now this is 2, this is 3, and here I have 1, 2, 3, 4, 5 divisions of my boxes. So if that's the case, I will just need to take it as this. The first one here is 2.2, this will be 2.4, this will be 2.6, this will be 2.8, and then you can see it's not 3.0. I'm just having incremental values of 0.2 units. So if I'm going to just take that, I can easily see that 2.6 is coming somewhere here, and the point of intersection here is what I need to note. So if I'm to know that, I will see that it is just coming here on the graph. That is the graph for, that's the point of intersection for x to be 30 and y to be 2.6. and then when x is 45, y is 3. That is quite straight. And now because it's a trigonometric graph, it's going to be a sinusoid. It's just repeat, like it's going in this positive axis, it will also decline with the same value, and that is why you can see when x is 60, y is what, 2.6 again. So it's just here, you can see that it's symmetrical with this initial value, just on the same line, 2.6 and 2.6. In the second case, it will be 75 and 1.5. So 75 and 1.5 that we got initially. You can see how it's shaping out to be symmetrical. When it is 90, when x is 90, y is 0. So here we have the 0 and 90. So when x is 105, y is minus 1.5, and just like we got it initially, this will be 105 and minus 1.5. When x is 120, y is minus 2.6, and minus 2.6 is going to be here. Just a reversal of what we did on the positive y-axis, okay? When x is 135, y is minus 3.0. So 135 and minus 3.0 just here. And then when x is 150 degrees here, again it is minus 2.6. So minus 2.6 here. Oh, interesting. So that's how a sinusoidal curve looks like. And then the task that is now left for us is to join all these dots together and get the sinusoidal curve as appropriate. And that's what I'm going to do. For you, the student out there, you can easily make use of your French curve, or if you have a very flexible material, maybe a broomstick, or there is a rubber curve that is normally available in the market, you can also use that. But here in my digital tool, I'm just going to use freehand, but I'm going to try as much as possible to ensure that all the lines are joining together and it's going to form a sinusoidal curve. All right, so let me just try and do that. All right, so that's my sinusoidal curve, and of course we are stopping at 150 degrees like this. So this is the curve for y is equal to 3 sine 2x. As a rule of thumb, always make sure that you label your graph. Okay, this is the answer to question A, this is the answer to question B, and then we need to look at the solution to question C. And here we are told that 3 sine 2x plus 2 is equal to 0, but we've been able to ensure that this is the same as y is equal to minus 2. Okay, so we can just draw our straight line. This is minus 2 on the vertical axis, and we can just plot our graph straight. So we can also correctly label this to be 3 sine 2x plus 2 is equal to 0, or you can say y is equal to minus 2. Okay, any one of the two will be suitable for you to define that. So for us to find the true set of this, we need to look at the point of intersection of this straight line graph and the graph that we are looking at initially. So this is that point of intersection, and we can trace it to the x-axis to just get that particular value. So that is quite straight. Let me just make that some broken lines so that you'll be able to see it appropriately. So how do we get the value for this particular solution here between 105 and 120 degrees? Okay, we are going to look at it this way. Here there are 5 divisions in the box that I'm considering as 2 centimeters. So I can say 5 is corresponding to 15 degrees, because between 105 and 120 is an incremental value of 15 degrees. You can see we are told 2 centimeters to 15 degrees on x-axis. So I want to get what one box will correspond to, so I can call that x. If I am to cross multiply, I can say 5x is equal to 15 degrees, such that if I divide both sides by 5, x, which is the value for each of the box, is going to be 15 over 5, and that is 3 degrees. So that means that in this particular case, each of these small boxes will take 3 degrees. So I have 105 plus 3 is 108 plus another 3, that will be 111 degrees. All right, so I can say in that case, for y is equal to minus 2, the truth set is given as x, such that x is equal to 111 degrees. To leave some margin for errors, you can say plus or minus 1 degrees. Okay, so what I got originally was 111, but I'm just leaving a margin for error of 1 degrees, and that will be the solution to 3 sine 2x plus 2 is equal to 0. But that's not all. In the second case, we're told that 3 over 2 sine 2x is equal to 0.25. Okay, and for that, we're able to get the expression of y to be y is equal to 0.5. Okay, so for y is equal to 0.5, we just need to go to the point at which we have 0.5, which is on the positive y-axis, and that is here. So we draw a straight line, okay, just to cut the graph for the sinusoid that we have initially. So we're going to have something like this. So that's our curve for y is equal to 0.5. And you can see, different from what we had initially, here we are going to have 2 solutions, one here and one here. And just like we did before, we can just trace that down, and also here, trace it down. In this fourth case, we have incremental values of 3 degrees. So here is 3 degrees, here's another 3 degrees, that is 6 degrees. But this our solution is closer to 6 degrees, so we can say it's like 5 degrees. So the truth set here, the truth set for this second case is defined as two cases here. So we have it defined as, in the first case, x, in which x is equal to 5 degrees plus or minus 1 degree, okay, or x in which x is equal to, what's the other solution? Here we have 75, okay, and we have 1, 2, 3 boxes. So we have incremental values of 3. So 3 in 3 places, that will be 9. So 75 plus 9, that will be 84. So we have 84 degrees plus or minus 1 degree. So this will be the solution to this other equation in which we are told 3 over 2 sine 2x is equal to 0.25. So we can reflect that here, that this is the graph for 3 over 2 sine 2x is equal to 0.25. Or, like I said initially, you can say it's just y is equal to 0.5. Either of these two, defining the straight line graph, will be sufficient. Okay, and just like that, we've been able to look at this question holistically and provide the solution that we're asked to actually provide as appropriate.